Welcome to SIM-PAC Live, where the rubber meets the road. I'm your host, Jeff Matthews, and today I interview Adrian Jones, one of the founders of Blocktexx. Blocktexx is an Australian company that's developing leading-edge technology that can forge a pathway for sustainability across industries that are struggling to close the loop on textiles manufacturing. These materials currently have no end-of-life use. Welcome, Adrian.
Good morning, and thanks for having me on the show, Jeff.
Yes, thank you for coming. Now, Adrian, recently I posted on my LinkedIn profile a photo of clothing piling up in the Atacama Desert. And what made it so wrong, it was photographed from space. And it was virgin clothing, apparently, left over from the COVID from some of the major brands. And I posted it and said, this is wrong on so many levels. And I made a promise to interview people that were trying to do something about this, that we have to do something as a planet to do about it. And I know that many people might say, we just got to stop producing it. We've got to kill fast fashion in its tracks, and we just got to consume less. But we still have to find an end-of-life use for those materials. And when I started reading about Blocktexx and what you do, I was excited, and thank you for coming on the show, because I've had this in the back of my mind to talk to somebody who was doing something about the problem. And your technology, it can separate polyester from cellulose. And tell me, give me a backstory first, because I'm always interested in the backstories of how these technologies, these groundbreaking technologies, get going anyway.
Certainly. So before I leap into the what we do, let me explain how I got here. My background was always in fashion and textiles, both in the UK, Europe, and then for the last probably 18 years in Australia. During that time, I came through a buying route, through a product development. So I've always understood textiles. As I got to, I was a CEO of a couple of large retailers here. And as I got to the end of my corporate career, it was because I was starting to question and wonder what happened to all the garments we were increasingly selling at discounted prices, and describing them as waste when they're actually a very valuable resource. I mean, every buyer can tell you the cost of their garment, how much the fibre cost, how much it cost us to make the garment, but then we seem quite happy to just throw them away as though they had absolutely zero worth. And this was a sort of a paradox which fascinated me. So I had the pleasure to, through a mutual friend, meet my business partner, Graham Ross. And we started Blocktexx with a simple view to keep textiles out of landfill. And that view has kept with us all this time. But obviously, as we've gone through our process of evolution, we've had to become more specific on what we do and how we do it, which is how we've ended up with the technology type that we have. There are multiple technology types out there. There is mechanical recycling, there is chemical recycling of textiles, and we firmly sit in that chemical textile recycling camp. And
describe that chemical process. I mean, I assume this is proprietary technology you've developed, and describe how these materials are broken down, what you end up with, and where does that go?
Okay, so yes, Blocktexx actually started out looking at the mechanical options for recycling. One of the challenges we identified early in that space is that ultimately you are producing a blended product. So just because something is made of polyester and cotton, if you chop that up or make it into a thread or into a packaging material, it's still a blended product which people struggle to ascribe a value to because they don't quite know what it is. So we worked closely with several universities in Australia and brought our own smarts to it, and we invented and then patented our separation of fibre technology, or our SOFT process, which actually is a chemical process by which we take blended fabrics, which are always the most hardest to recycle because they can usually comprised of polyester, which is made from oil, and cotton, or another man-made cellulosic such as viscose and rayon, but they are blended together as a fibre. Therefore, they are quite difficult to separate. What our chemical process does is that by a chemical reaction, by the use of heat and pressure in an optimized set of circumstances, which took several months of experimentation to discover, we can now separate polyester cotton fibers, fabrics, garments, and we separate those into a polyester work stream, and we separate those into a cellulose work stream. Cellulose is the building block of cotton. And the polyester work stream is washed and dried, and then it's re-melt extruded. So we add certain chemicals to that melt extrusion process, and we rebuild the quality of the polyester. And so at the end of that process, we produce rPET, or recycled polyester, and that's our Polytex product. The cellulose is dewatered, i.e. centrifuged, and all the water is squeezed out of it, and we produce a thick clay. Imagine it looks a little bit like pizza dough, and that cellulosic clay, or a Celtex product, is then used for, we then sell that on into other industrial uses. What I would add, Jeff, is that both of our products are capable of, and we're doing a lot more research in this space, are capable of going back into fibers, but there is no fibre industry, there's no spinning industry onshore in Australia. So given the fact we've only been in production since the start of this year, and our volumes are now building, we are now starting to work with offshore mills with the view to say, could we convert these recycled fibres back into new fibres? But in the meantime, we've found onshore uses for the Polytex, for the recycled polyester, and that essentially goes into areas such as injection moulding, which there's still a large demand for that onshore in Australia. And the Celtex, or the cellulosic product, goes off into a hydro mulch product, and it's used to convert, it's blended with other products such as wood chip and grass seed, and it's essentially used as a fertilizer to reclaim and rebuild soil and land after mining or after infrastructure projects. So we've done some trials, for example, at the Greater Western Sydney Airport, and that lovely green grass growing on the side of the new runways, that was sort of powered, if you will, by our Celtex product.
And that's sort of a replacement for bark would traditionally be sort of used for that, to put seeds and stuff and other thing onto it too.
Yes, absolutely. I mean, the advantage of the advantage of our cellulose is that it's rich in both carbon and it's rich in water, because cellulose holds water very well, and so it is still blended with wood chip. It is still blended with grass, and it's blended with other and compounded with other materials. But essentially, it reduces the need to put virgin cellulose, or reduces the quantity of virgin wood pulp that is used in the hydro mulch.
Right. Okay, a couple of questions then. The chemical process, I'm assuming that you've got some sort of closed loop process on that we're not putting more toxic chemicals in the environment during that process. Just, how's that contained, and how how non-polluting is that? Is it, are these harsh chemicals that you're using, and how do you contain them from getting in the environment?
Well, there's two expressions we use a lot in Blocktexx. The first is that we want to keep textiles out of landfill, and the second is, and I think this is important because this guides a lot of our business decisions and our process decisions, is that you can't make a problem for somebody else. So there's no point saying you're recycling and doing all the right things if you're then producing another waste stream which somebody else has to deal with. So whilst I'm not going to go into the exact chemicals that we use, at the end of our separation process, we actually produce our product that comes out of the bottom of the reactor, so to speak, is not only the separated polyester and the separated cellulose, the rest is water. And we recycle about 85% of that water. So we reuse the output of the process because it's neutral water, and so we reuse that water in our own because it contains heat, and we've heated it, so we try to divert energy utilization. But that's if you're defining what waste do Blocktexx produce, well, actually we don't. We produce water at the end of our chemical process, and that water is recycled.
Wow, cool, very cool. And is there, other than the polyester and the cellulose, is there anything else that's left over? Is there any other waste that you've got to deal with, or is they the two component pieces that make this up at the end?
Well, what we've just described is what happens within our facility in Queensland.
Yeah.
So that it describes, as we call it, what happens after the gate, i.e. what is delivered to us is a shredded material, and we process 1,000 kilos an hour, so we process a lot. But what is delivered to us is material ready for the chemical process, so it's shredded and it's ready to go into the process. Now, we also have a before the gate business because, as you can imagine, we take textiles from a wide variety of sources. We take linens from hotel chains, we take commercial uniforms, we take workwear, we take schoolwear. Now, the challenge with all of that is it hasn't actually been designed for the end of life. It's been designed for use in life. And so it naturally contains furniture, such as buttons, such as zips. It contains elastic in the waistbands. Now, what we've now built is our before the gate business, where we engage with social enterprises, we engage with the correctional services system, and we employ people to remove those buttons and to remove those zips. So that leaves the material free of all of those, all of that furniture, so that can then be shredded and enter our process. And those materials that are left, buttons or zips, if they can be recycled, e.g. metal zips, metal is always very capable of being recycled. Some buttons are capable of being recycled. But in a garment that we recycle or we treat, when it's in our factory, we capture about 95% of that fibre. But we have to take the material off that fibre before it comes to us. And depending on how complex the garment is, that can be between 2% or 10% of the garment is actually taken off and removed because it can't be recycled currently. So, recognising that as a problem, what we also have within Blocktexx is that we have our own design services. And so members of our team come from a fabric and garment design background. They've also spent many years in the recycling industry, and we have a whole library of products that can be recycled within the Blocktexx process. So we've had some very successful meetings with clients where we would say, if you replace this nylon button with a polyester button, the whole garment can be recycled. And often, and that's the clue to the future of increasing textile recycling, it's thinking about the end of life in the design stage. Because at the moment, we have to react to what is in the market. That's not a criticism, it's just a truism. But going forward, we should bring our smarts to design garments for the end of life, so the recycling of them and the remanufacturing of raw materials is significantly easier.
Yes. I recently recorded a show and talked about Norway being the most successful recycler of plastic bottles and drink containers, and looking at why they were, it was because they regulated, and I think there were only 3 different types of plastics they were allowed to use in the tops, and the labels, and even they were restricted on adhesives. And what that meant is every recycler in Norway could deal with it, rather than being able to use this one and having to send that one to Czechoslovakia and that one has to go to Africa somewhere. So, regulation at the top as well to restrict enables better outcomes for recycling. And as you said, if it's a choice between a nylon and a polyester button, I mean, really, those things they've got to be stopped coming into the chain at the start. So,
well, I think about that. The way to reduce waste is to design it out.
Yes.
You can't get to the end of the cycle and go, now I want to be waste free, because it just doesn't happen like that. Because if you think about the components of garments, and not just our own personal clothes, but think about our school uniforms, our work uniforms we expect, the military, the police, the fire, by their nature, they are very, very complicated. Now, that's just a feature of how they have been designed. Now, in no way, shape, or form is Blocktexx saying we should design garments that are uncomfortable or unsafe just so they're easy to recycle. But actually, yes, it isn't like that. You can't change the design of a garment so it is 100% recyclable at the end through our process. And the advantage to the client is that it actually lowers the cost of recycling. So by working on the design stage, you actually have a virtuous circle by which you can actually then recycle the same garment, but at a lower cost, which encourages more people to enter the textile-to-textile recycling market. I think the other point we need to talk about is legislation is good at the front end, so you have good design products, but you also need to have legislation and purchasing agreements in place at the back end to make sure that there are markets for the recycled product. Otherwise, you kind of have a one-sided equation, and that's not particularly healthy for any kind of business.
Yes, and also we can't just be exporting the problem to somewhere else. The Atacama Desert or Africa. I'm giving a couple of speeches about aluminium in the next couple of months, and one of the problems about it's a recyclable metal. But actually, we export in Australia here. We export 95% to be recycled. We use 3 billion cans, aluminium cans a year in Australia, and virtually it all goes offshore. And so, how do you create a market in Australia for recycling? Is at some stage you've got to step in and stop the export of materials that could be recycled onshore from being exported offshore. And
well, I think that's very right. And I think over the last few years, for example, in certain types of plastics, we've seen policy taken by other nations, e.g. China, and then some of our near Asian neighbours stopped accepting soft and then hard plastics as a waste stream, because their view was, do we have the infrastructure to deal with, and also do we want to be famous for just recycling other people's waste? And I think, therefore, that's led to an increase in the innovation investment in the recycling of soft plastics, hard plastic bottles, drink containers, etc. onshore. And there's some of the great works being done in bottle-to-bottle recycling. Now, a drink bottle, whether that's Fanta, Coca-Cola, whatever your flavour is, that is the same chemical as probably 60% of the garments that we wear. The polyester used in a Coke bottle is the same as the polyester used in a shirt. So it somewhat strikes me as paradoxical policy, where you've said, we'll ban the export of Coke bottles, but we won't ban the export of clothes containing the same plastic. Now, I think that is an interesting policy position which needs to be revisited. And I think the way to start that, and what Blocktexx would certainly advocate, and what we certainly would support through ACOR, the Australian Confederation of Recyclers, is if you take unwearable clothing, i.e. the clothes that's torn or ripped or stained, that should be banned now. Because if it's unwearable here, it can't be wearable anywhere else. If there's a viable market for the reuse of second-hand garments, then we should look at that over time and say, how do we modulate that and reduce it over time? But we're not advocating that we reduce that today. But unwearable clothing, I fail to see how a torn or stained or ripped T-shirt that's unwearable in Australia somehow transforms itself to becoming wearable in another economy.
Yes. Yeah, yes, totally agree. Now, in your Before the Gate collection, if you get, say 100% cotton T-shirt or something, does that it obviously doesn't go through your chemical process. It goes through another process.
It goes through the chemical process.
It goes through the chemical process as well.
Chemical process.
Okay.
Everything in our facility goes through. As we play tunes, we're a little bit like alchemists. We play tunes because we understand our yields from our product. Yeah. And to reduce, if you just take cotton and you don't chemically process it, you remain up with cotton, but just much shorter fiber lengths, which doesn't have a lot of uses. By going through our process, we change the cotton to to cellulose, one of its building blocks, and then that has a real industrial use. So we work very hard to filter and understand the composition of the fibers coming into our factory, and then we play tunes about how we mix it, the blends we've got, because we understand what yields we want for our outputs as well.
Okay, so that's quite an important point, because a 100% cotton t-shirt can compost. It's organic, it can compost, but that's its total end of life, where you're processing it and putting it back into a building block material that has another commercial use.
Well, what I would ask you to challenge, I would challenge you on that one statement. When you say your cotton t-shirt is 100% compostable, well, what about if it's got polyester threads? What about the nylon label on the inside? What about maybe it's got sort of anti-slip tape on the shoulder? All of those are plastic. They do not decompose in the ground. So we have to be careful with statements that it's a cotton t-shirt, I can compost it, because it might not be. Like underwear, probably 90% of underwear is made of cotton, but there's also elastic in the waistband. There's elastic. So I think we have to make sure that we apply our smarts and scientifically deal with the problem thoroughly, so we're not introducing microplastics or smaller amounts of plastics back into the environment by just assuming we can throw our cotton t-shirts onto our gardens. I'd probably recommend that you don't do that.
Yeah. Good point. Okay, good point. So let's talk about the cost and let's follow the money for a bit, because assuming is this financially, does this stack up by itself? Do you get enough for your end materials that you're selling back commercially to sustain the process, or does it require funding of the process coming in at any stage?
Graham and I have been in business a long time. Businesses have to primarily have a purpose, and a strong environmental purpose and social employment purpose in Blocktexx, but they also have to be financially viable.
Yes.
Recycling for recycling's sake, as I often say, is a very pleasant way to go broke really quickly. So we've structured our business and our model. So yes, we charge a gate fee on the way in, which is a fee we charge to our clients merely to cover the cost of transport of that material, which is quite a high cost in Australia. The transport of that material from various collection points to our facility in Queensland. And we charge a proportion of that is for the wages that we pay in the disability services sector. In the correctional services sector, we don't expect anybody to do things for free. We actually pay people a living wage. So, but we don't look to make a profit on our front end. So our gate fee is purely, for Blocktexx, is purely about cost recovery, because we do have a significant back end. By the time we've gone through our processing, we understand that we can sell our products in market at a cost that gives a reasonable return for our business and for our investors. So our business model, Jeff, is very balanced. Yes, we charge a gate fee on the way in, but that's not how we make our money. We make our money after we've incurred the cost of manufacturing. When we sell our product, when we sell the Polytex and the Celtex, that's where we make a reasonable return for our investors.
And I'm assuming that reasonable return is that sort of, how does it stack up with the cost of virgin material?
Well, again, I'm not going to get specifically into the details of our unit economics, but when we started this business, polyester or cellulose, they are a commodity. They are traded regularly. You can go out and say, what's the price for 1 ton of virgin material? What's the price for 1 ton of recycled material? Those prices are known. And so we started the business from the back end forward and said, in the market, we have to make sure that we can match the current pricing in the market. Now, whether that pricing remains the same over time, but we have to be able to match that. And then we've engineered our processes back so we can meet those prices. Is there a premium, a small premium you can charge for a small period of time because you have the early adopters, the innovative start, you have that allows you to charge 5 to 10% over market rate because it's brand new and everyone wants to be in? Yes, I think you can. But we've always marked our our costs of manufacturing and our costs of products to market, because otherwise you're not really going to make much of a business of it. But I do think, as we saw recently in certain European countries, where to catalyse the market, I don't believe government should come in and say, we're going to back mechanical recycling, or we're going to back... It's not for governments or government policy to pick the winners in the industry. It's to provide the ecosystem that allows all players to compete fairly to get to an end point and see who is the most successful. So what you saw in Europe is that they said, in certain economies, we are going to insist that government contracts have to contain a certain proportion of demonstrably onshore recycled material. Yes. And so if you're a government purchasing department, 20% of your purchasing had to be demonstrably, using this example, demonstrably Australian recycled rPET. What that did was, for a period of time, it decoupled the price of virgin from the price of rPET.
Yes.
Because actually there was for a period of time, there was a shortage of supply. That increase in price brought more participants into the market, and therefore that stabilised the prices, but on a much higher production base. So I think that's a role government can play in in building a sustainable circular economy. It's not to pick and choose the technologies that will be successful. It is to choose. It is to make sure the market conditions are set that allows those industries to be successful.
By being a big player in the domestic market themselves.
Indeed.
As the government purchasing. Yes. Okay. So you're an Australian company. You've had a fundraising round. You've got sort of a certain amount of money in for an A funding round. Are you going for B? What's your plan? Are you going to go and conquer the world? Are you going to license to the world? Where's the expansion plans?
Absolutely. We have been through 2 capital raises. We're just finalising a Series B now, and that has capitalised the business to allow us to both build our first plant in Queensland, and that will also allow us to expand this first plant in Queensland also. But our plans after that are definitely expansionary. We want to build more plants in Australia, but we also know our solution has to go to the problem. Apropos your aluminium discussion, I think we could import textiles from wherever, but we're not really solving the problem. We're just we're adding more carbon to a carbon-intensive industry anyway. So we see Blocktexx licensing our technology in a variety of economies. We've had multiple approaches from players in our near Asian market where there's a high degree of garment manufacturing. There's a fairly underdeveloped recycling infrastructure, and therefore the opportunity for us to rapidly license our technology stack around the chemical engineering, the mechanical engineering, the business smarts wrapped around that. I think from a growth perspective, 2-pronged: more plants in Australia, but also licensing our technology overseas.
And I'm assuming some of those manufacturers in Asia, they're also looking to put an end-of-life solution to their garments before they sell them up front. Because at the moment they don't have an end-of-life solution, and they would be looking for your technology as sort of pointing in that direction for their garments when they sell them.
Well, I think we always talk about textiles as opposed to garments, because I think garments ends up being quite limited because it tends to define it as a post-consumer issue. When if you think about textiles, they're everywhere in the supply chain. So when garments are made, there is cut scrap, there is industrial textiles that sadly are wasted at the start of the process. If there are offcuts, there are mistakes, there are all sorts of things that actually happen before they even get into the hands of the consumer. And then, of course, there is the post-consumer waste. So our argument and our discussions, positive discussions, have been in large manufacturing countries near us, have been to cite a Blocktexx technology within your value chain. You can provide the input stock because you have cut scrap. You have consumers who buy your product who can provide the output, can provide other types of input stock, but also because you use polyester, you can actually then become a purchaser of the outputs to go back into your spinning process to produce more textiles. As I said at the start of the conversation, we don't have a spinning industry in Australia. We haven't had for many years now. And so the opportunity for us to become sort of sit in the middle of somebody else's value chain where we can provide, they can provide inputs and we can provide outputs, which become their inputs again. That's true circularity.
Yes. Great stuff. Great stuff. Look, thank you very much. It was a great chat. It was great to meet you. I'm excited that somebody's in this space doing something. I wish you all the best. We hope to see you at SIM-PAC in 2024, and another Australian piece of technology that looks as though it could go and have applications all around the globe on huge scale. I wish you all the best. Thank you, Adrian.
Thank you for your time, Jeff, and always a pleasure to talk about Blocktexx.